Hi everyone, welcome to your Human Nutrition 101 final exam review session. Your final exam, the format is going to be exactly the same as the midterm exam, 100 multiple choice questions, and the materials covered on the final exam include everything that we've reviewed since the midterm. So even though we're not covering, the final's not covering anything from prior to the midterm, you will note that we have been building upon what we've learned since the first half of the semester. So the second half of the semester does include some cumulative knowledge, but we're not going back to anything before the midterm exam. So it focuses on everything that we've covered since the final exam. So again, you'll have 2 hours to complete it. 100 multiple choice questions. The best advice that I can give you is to focus on the specific learning objectives for each and every one of the chapters. So that's what I'm going to do today. I'm going to review those with you. So starting with the water-soluble vitamins, yes, I do want you to be able to describe the general differences between macronutrients and micronutrients. Remember, the macronutrients, carbohydrates, lipids, and proteins, have calories, that is, they have energy. The micronutrients do not, which include micronutrients include the vitamins and minerals. The macronutrients are required in larger amounts in the diet. Micronutrients are required in smaller amounts. And when you consider the fat and water-soluble vitamins, there are some general differences. Basically, the water-soluble ones are soluble or dissolvable in water, where the fat-soluble ones require some fat to be dissolved. So think about how that affects your body's ability to absorb the fat versus the water-soluble vitamins, as well as transport it around your body, store it, and excrete it. So in general, the water-soluble vitamins don't require any fat in the diet. They just require water. They travel, they're absorbed through your blood, they get transported through your bloodstream, and they get excreted in your urine. In general, the fat-soluble vitamins, on the other hand, remember those are A, D, E, and K. The water-soluble vitamins are the B vitamins and vitamin C. The fat-soluble ones do require a little bit of fat in your meal in order for them to be absorbed, to be incorporated into the chylomicron, so they can be absorbed into your lymphatic system rather than your bloodstream. And that has implications for storage. Fat-soluble vitamins are stored in your fat, fatty organs, the fatty parts of your body, to a higher extent, or stored in general to a higher extent than the water-soluble vitamins. And the fat-soluble vitamins are not readily excreted in your urine. Instead, they get excreted through bile and end up in your feces in general. Okay, so think about where you would find fat versus water-soluble vitamins in food. If you removed the fat from a food product, chances are you're also removing the fat-soluble vitamins with that fat. So keep that in mind. So with regard to the B vitamins, remember, that's B1, B2, B3. That's thiamine, riboflavin, niacin. Their common function is that they act as coenzymes. That is, they help enzymes do their job to catalyze a reaction or move a chemical reaction forward. So those are the major functions of those B vitamins. For B6, B12, and folate, their major function is to help with amino acid or protein metabolism. That is, to break down proteins and into amino acids, and for amino acids to be used in your body, as well as creating DNA. So those are the common functions of B6, B12, and folate. The major sources of each of the B vitamins. In general, the first 3 B vitamins, B1, B2, B3, you're going to find in whole grain products as well as in rich grain products. And the reason they're in enriched grain products is because during the enrichment process, you're required to add back just B1, B2, B3, as well as iron. So those are the only things that you're required to add back, at least in grain, refined grain products when you enrich them. You also need to add back folic acid or fortify those greens now with folic acid. We'll talk about that when we talk about some of the functions of the B vitamins. Well, let's talk about the functions of folate. Folate is required not just for DNA synthesis, but in its capacity as being required for DNA synthesis. It is required during pregnancy to prevent neural tube defects, the most common of which is spina bifida. So major food sources of B vitamins. So the first three, B1, B2, B3, you find primarily in whole and enriched grain products. B6, you also have some unique sources of them. So B1 you also find in things like pork. Riboflavin is unique because you find it in milk. So milk and dairy foods are a good source of riboflavin. Niacin you find in meats as well as B6. And B6 makes sense because if it's involved in protein metabolism, you find B6 in meat. B12 is interesting as well because you only find it in meat. You only find it in animal-based foods. You do not find B12 in plant-based foods, and this is a problem for vegetarians and strict vegans who restrict all animal products in their diet. So be aware of that. Folate, besides being in fortified grain products, you also find it in foliage, green leafy things. Okay, so those are the major sources of each of the B vitamins. Major deficiency diseases associated with each. Well, think of the classic deficiencies. So B1, classic deficiency of thiamine is beriberi. Classic deficiency of riboflavin is ariboflavinosis, which consists of cheiliosis, which is those cracks at the corner of your mouth, and inflamed tongue. Classic deficiency of niacin is pellagra. For B6, you know, I really don't need you to remember that one, but there is a type of anemia that's associated with low B6. And remember, anemia just refers to a low red blood cell count. Most anemias are due to iron, but a lot of other anemias are due to deficiencies or interference with other vitamins as well as minerals, including B6 and B12 and folate. Deficiency disease with folate could be cancer, but in pregnant women, it is the increased risk of neural tube defects in their fetus. For B12, it's irreversible nerve damage. And the reason why B12 is also important is because with regard to deficiencies, especially as you get older, is because you do require some stomach acidity in order to be able to digest or extract B12 out of the protein-containing food, the animal-based food in which it's provided. So as we get older, our ability to produce stomach acid is reduced. So remember, that's going to affect your body's ability to absorb B12, especially as you get older. Major uses of vitamin C in the body. Remember, that is an antioxidant. So vitamin C as well as vitamin E and beta-carotene, the plant-based form of vitamin A, are also considered the antioxidant vitamins. The other major function of vitamin C is its ability to activate collagen, which is this protein in your ligaments, in your tendons, in your skin, and it helps maintain the integrity of collagen. So that means it helps maintain the integrity of your skin and your gums. And the classic deficiency of vitamin C is scurvy. One of the first symptoms is bleeding gums. You'll also see little pinpoint hemorrhages in your skin. These are points in your skin where the collagen is no longer intact, or the integrity is compromised. Toxicity of vitamin C, it really, it's really diarrhea, basically. High doses will cause diarrhea, but it also cause some interference with some medications. And the major food sources of vitamin C include citrus fruits. So fruits are a really good source of vitamin C. So now let's talk about the fat-soluble vitamins, A, D, E, and K. Roles of vitamin A in the body. Remember, the primary role of vitamin A is in vision. Effects of vitamin A deficiency. Well, the first sign of a vitamin A deficiency is night blindness, and then that progresses to irreversible blindness called xerophthalmia. Too much vitamin A can actually cause liver damage, and it can increase your risk for hip fractures. Major food sources of vitamin A. Remember, there are two forms of vitamin A, the preformed or retinoid form that you find in animal-based foods like eggs and dairy and liver, and beta-carotene or carotenoids are the plant-based form of vitamin A that you find in plant-based foods, or plants that are really colorful, mostly yellow and orange and some green in them. So that is where you find the carotenoid form. Beta-carotene is the most commonly identified and most common carotenoid that we find in our food and in our body. Uses of vitamin D in the body. Well, bone health. Primary function of vitamin D is in bone health, and what it does is it helps your body absorb calcium, and calcium gets laid down into your bones. So that's the role of vitamin D in bone health. Too little vitamin D means that you're going to have some compromised bone structure. In children, a lack of vitamin D is called rickets. In adults, it's called osteomalacia. And this is just a softening of the bone, so you'll have these bowed legs is a classic symptom. Toxicity of vitamin D, just the overaccumulation of calcium in your organs. Major food sources and non-food sources of vitamin D. Remember, vitamin D you don't really find in a whole lot of food sources. You find it in fortified dairy foods and fatty fish like salmon. You know, you can find a little bit in eggs, but that's about it. And if your dairy products are not, like yogurts, are not made with fortified milk, then there may not be that much vitamin D in your yogurt. So always read the label. Non-food sources of vitamin D, remember, sunlight. Sunlight hits your skin. So your skin is one of the three organs that's involved in the conversion of vitamin D. Sunlight to active vitamin D in the body. So skin, and then your liver is involved, and your kidneys involved. Your kidneys is where the active form of vitamin D is made primarily in your body. Identify the role of vitamin E in the body and the effects of vitamin E deficiency and toxicity. Vitamin E, again, it's an antioxidant, just like C and beta-carotene. The effects of vitamin E deficiency. This can cause one of the vitamin-related anemias because vitamin E protects the fatty acids in your cell membrane from getting attacked by free radicals, those oxidants. It can help keep your cell membranes intact, and if this is a red blood cell, that's important because if you lack vitamin E, that might increase your risk for those red blood cells from bursting and dying. Vitamin E also, because it acts as an antioxidant, it can protect your lipoproteins, especially your LDL lipoproteins, from attack by free radicals, or it helps prevent the oxidation of your LDL particles. Remember, those are the transport vehicles for cholesterol in your body, and if they do get oxidized, that starts to trigger one of the early events in the development of heart disease. So that's one of the roles of vitamin E. Too much vitamin E, basically, it can cause excessive bleeding. Major food sources of vitamin E, you find it's fat soluble. You're going to find it in fat soluble foods like plant oils and nuts and things like that. You just find a little bit in some vegetables like asparagus. Major role of vitamin K in the body. Remember, vitamin K, think clotting, blood clotting. So too little vitamin K, you're not going to be able to clot. You're not going to be able to form a clot where you get cut. So you may bleed excessively. That's called hemorrhaging. Toxicity of vitamin K is really only a problem for people who are on some of these anticoagulant or anti-clotting drugs. These are heart patients. Food and non-food sources of vitamin K. Food sources, again, plant-based oils, a lot of green vegetables, broccoli, And you also find some vitamin K produced by your gut bacteria. The bacteria that are living in your colon or your large intestine, they produce a little bit of vitamin K, but not enough to meet your needs. That's why it's still an essential nutrient. What else? ADEK. Define the term antioxidant. Anti means against. Oxidant. Oxidants are free radicals. Free radicals do damage to your cell membranes, the fats in your cell membranes. They can damage your DNA, and they can damage your proteins and affect cell function that way. And the vitamins that act as antioxidants in the body, or beta carotene, I should say, the carotenoids, vitamin C, vitamin E. And also, we're going to talk about minerals in a second. I need to mention that selenium even is also considered an antioxidant, even though it doesn't directly combat free radicals. It doesn't directly act as an antioxidant. It acts as a cofactor for an enzyme called glutathione peroxidase. You don't need to know that name, but it acts as a cofactor for an enzyme that acts as an antioxidant. So in this capacity, you would lump in selenium under the category of antioxidant nutrients. All right, so that's fat-soluble vitamins. Let's talk about water. I had you review your online lecture on water on Trunk. It's only 10 minutes long, so please make sure you review that. You'll see there's only 2 objectives here, the major functions of water in the body, so make sure you review those major functions. And water balance. I want you to know the 3 ways in which water enters our body, or 3 ways in which we increase the amount of water in our body, and the 4 ways in which we lose water from our body. So when we're thinking balance, remember, just like energy balance, it's energy in versus energy out. What are the components in? What are the components out? Same thing with water balance. The 3 components in include beverages, including water, but other beverages as well. Foods, we get water from our foods. Certainly fruits and vegetables are high in water, but you also find some water even in pizza. It's 50% water, but as the higher fat content of the food, the lower the water content of that food. So oils have no water, cheeses have very little water, but a lot of foods provide a substantial amount of water in our diet. And don't forget that during energy metabolism, one of the 3 products of turning down or churning out our macronutrients into energy, the form of ATP, that energy metabolism pathway not only produces ATP and carbon dioxide, it produces water. So our bodies produce a little bit of water through this energy metabolism pathways. So those are the 3 ways you get water in. What are the 4 ways you get water out? Well, water leaves your body through urine, of course. It also leaves your body through your feces. So as you excrete food, you're also excreting the water from those foods in your feces. Every time you perspire, you lose water, and your body is constantly perspiring. Whether or not you see visible sweat, well, water is leaving your pores in your skin. So that's a 3rd route. And also the final route is when you exhale. Every time you breathe out, you're breathing out carbon dioxide plus a little bit of water. So you're exhaling water vapor. Now, when you're considering why is water balance important, because when you're considering how much water you need to consume in a day, what are the requirements for water, it's really based on the amount of water that you lose through those 4 routes. So you should have a good idea of the amount of the range of recommended range for water intake. So have that one in your head before you go into the exam. All right, the minerals. Let's start with the major minerals. Remember, major versus minor minerals or trace minerals, and minerals versus vitamins. Vitamins are very easily destroyed by, excuse me, some of them are more easily destroyed by some things than others. So by sunlight, oxygen, heat, too much acidity, too much alkalinity. Vitamins are more susceptible to degradation than the minerals. The minerals, you can burn a food completely to ash and still recover the minerals. It's really, really hard to destroy the minerals. General function between major minerals and trace minerals. The major minerals, you need them in larger quantities in your diet. versus the trace minerals, because the major minerals are also present in larger quantities in your body than the trace minerals. So speaking of the major minerals, remember, try to group them. Calcium, phosphorus, magnesium are the three major minerals whose major function is bone health. So calcium, major role is a component of your bones. And there are some things that can either enhance or promote or inhibit your body's ability to absorb calcium from your foods. So things like acid, stomach acid, acidic foods can increase the absorption of calcium, as well as other minerals like iron in your diet. And things that limit its absorption, remember, vitamin D also enhances calcium absorption as well. So make sure if you're taking a calcium supplement that it has some vitamin D in it. Things that limit the absorption of calcium as well as other minerals include a high amount of fiber, especially fiber that contains these phytates and oxalates that you find in things like wheat bran and spinach, because they are these compounds embedded within the fiber that are highly negatively charged, and the calcium is highly positively charged. So those phytates and oxalates can bind the calcium and prevent it from getting absorbed. Hormones needed to maintain blood calcium levels. Remember, blood calcium is maintained at a steady concentration in your blood, just like your blood glucose, and your blood glucose levels are controlled by insulin and glucagon. Well, your blood levels of calcium are controlled by two hormones, parathyroid hormone, or also called parathormone, and calcitonin. So remember those two. Identify food sources of calcium. Describe the effects of calcium deficiency. So food sources of calcium, dairy products, whether or not they're fortified, include calcium. Even yogurt contains calcium, whether or not it's fortified. In addition to dairy-based foods, you also find calcium naturally present in some leafy greens. Again, some of the calcium from some leafy greens is more readily absorbed than others, depending on their fiber content. And you also find calcium in some calcium-fortified foods. Describe the effects of calcium deficiency. Classic deficiency is osteoporosis or porous bones. Risk factors for development of osteoporosis. The first and foremost, the biggest risk factor for osteoporosis is age. As we get older, we all start to lose bone density. That is, we lose more bone than we gain. So our bones become less dense, more porous, more susceptible to fractures. And this is why physical activity and calcium intake throughout your entire life is important. Calcium intake to help build peak bone mass during your growing years, during your teens and your 20s, your early 20s, because once you hit 30, you start losing more bone than you gain. So you reach your peak bone mass years within your 20s. And after that, it's just kind of downhill. So getting enough calcium during that time of your life, and vitamin D throughout your development up to that point, is super, super important to achieve peak bone mass. And after that, it's also important to help delay the loss or slow down the loss of bone that naturally occurs as you age. Physical activity is important because throughout your life, physical activity is important with regard to bone health, because as you move your muscles, the tendons on your muscles attached to your bone, they stress the bone and stimulate the bone to rebuild itself, to withstand the stress the next time you subject it to that stress. Major roles of phosphorus in the body. Phosphorus is found everywhere. In your diet, in your body, it's primarily found in your bone, but it's also found elsewhere as well. Food sources in the diet. Phosphorus is found in so many foods. It's really not a problem with regard to deficiencies, but getting too much phosphorus and not enough calcium is problematic, and this comes into play when you're considering the source of phosphorus is cola, soft drinks. If you replace milk with cola-based soft drinks, especially during your peak bone mass years, you could be interfering with your body's ability to absorb calcium properly, because too much phosphorus can bind to calcium and prevent it from being absorbed, and that's not good if you're trying to build bone. Role of magnesium in the body, again, a component of bone, major food sources. Remember, magnesium is also a component of chlorophyll, which is that green pigment that you find in plant-based foods. So any green leafy vegetable is going to be a good source of magnesium. You also find magnesium in nuts. The other three major minerals are the electrolytes, so sodium, potassium, and chloride. The role of sodium in the body is it's an electrolyte, so the role of sodium, potassium, chloride are as electrolytes. Sodium and potassium are antagonists. That is, too much sodium will actually increase your body's ability to hold water or swell up or get edema, and over the long term, the sodium may increase your risk for developing chronic high blood pressure. Not everybody is sensitive to the effects of sodium. People who are salt sensitive are more susceptible to the blood pressure raising effects of sodium. Major food sources of sodium, processed foods. That is the #1 source of sodium in the diet. Whole foods, or foods in their whole form, tend to have much, much less sodium, but whole foods also tend to have much, much more potassium. And you want more potassium in your diet than sodium because potassium can kind of counteract this blood pressure raising effect of sodium. So potassium, in turn, helps lower your blood pressure. And where do you find potassium in the diet? Well, fruits and vegetables are a great source, as is dairy. And this is the basis of the DASH diet, which stands for Dietary Approaches to Stop Hypertension. And it is a diet that recommends more servings of fruits and vegetables, and specifically low-fat and fat-free dairy, in order to increase the amount of potassium, displace the sodium in your diet, and help reduce blood pressure in people who have elevated levels. And with regard to chloride, the one thing I want you to remember about chloride, besides it being an electrolyte, is that it is a component of stomach acid, good old hydrochloric acid. Remember that? So that's what I want you to remember about chloride. So trace minerals, major functions of iron in the body. So really, when we're talking about trace minerals, I really want you to focus on iron. Iron is a component of hemoglobin, which is in your red blood cells, so it helps transport oxygen throughout your body. Availability of iron from plants versus animal sources. The iron that you get from animal-based foods is bound to a compound called heme, which makes it more readily available to our body than the form of iron that you find in plant-based foods. That is called non-heme iron. So plant-based foods that have iron, even though it may have as much iron, per gram of food as an animal source, because the plant-based food doesn't have heme, it's not going to get absorbed as readily. With regard to other functions of iron, remember, vulnerable populations for iron deficiency include women, or pregnant women, they're developing fetuses, growing kids, teens and adolescents, and most women of childbearing age up to the point where they reach menopause, which is around, on average, age 50. So the role of zinc in the body, it is a cofactor for more enzymes than any other or all of the other minerals combined. Major food sources, again, meat, just like iron. We also find it in grains. Consequences of a zinc deficiency, remember, classic deficiency, dwarfism, because you need zinc for so many enzymes. If you don't have enough zinc during the periods of growth and development, especially during adolescence, you're going to get stunted growth or dwarfism. Insufficient and excess iodine intake. The one thing I want you to remember about iodine is too much or too little will result in the same condition called an enlarged thyroid, which is called a goiter, but through different mechanisms. Use of chromium in the body. Remember, the one thing I want you to know about chromium, or remember about that, is it helps insulin do its job, and insulin's job is to help remove glucose from your bloodstream and put that glucose, or help escort that glucose into your cells where it can be used and metabolized. So that's the function of chromium. It helps lower your blood glucose by helping insulin do its job. Use of selenium in the body. Remember, we just mentioned when we talked about antioxidants that selenium does act as a cofactor for an enzyme that acts as an antioxidant. So in that capacity, it can work with vitamin E to do its job. The use of fluoride in the body, it's important because it can get incorporated into hydroxyapatite, which is that crystal in your bones that contains the calcium and the phosphorus to give your bones strength and your teeth strength. So when fluoride binds to hydroxyapatite, it makes it even stronger. So it helps you resist cavities. So that is the use of fluoride in the body. Major function: if you have too little fluoride, you'll get dental cavities. If you get too much, you'll get this mottling of the teeth, which is misshapen teeth that are brown coloring all the way through. I'm not going to ask you about the major phytochemicals that might protect the body from cancer and heart disease, but know that they are present in most of the plant-based foods. So things like flavonoids and resveratrol and lycopene and things like that. So physical activity, nutrition and physical activity. We had a couple of guest lectures, but I also wanted you to review the online lecture for this unit because that online lecture contains the materials that are reflected in your chapter on this. And the things I want you to remember from this chapter are to keep in mind the benefits of engaging in regular physical activity. Physical activity is so good for you for so many reasons. A couple of things I want you to have in mind: the components of fitness and the progressive overload principle. So components of fitness, when we define fitness, we define it as strength, flexibility, and endurance. That is cardiovascular endurance of your heart and lungs. So strength, flexibility, and cardiovascular endurance. So those are the components of fitness. And how we become fit is that we engage in those three types of exercise and apply the progressive overload principle, which is to do those exercises for a longer time, at more intensity and more frequently. So duration, intensity, and frequency are the three components of the progressive overload principle. When you are exercising, one of the first fuels that your body's cells use to generate ATP, to generate enough energy for you to engage, to support you during your exercise, is glucose. And remember, glucose is stored as glycogen in a finite capacity in your liver. So as soon as you deplete your body of glycogen, you may hit the wall. A lot of people did that during the marathon. What you want to try to do is engage in more moderate intensity activity to allow your glycogen stores to be released more slowly. So engaging in moderate physical activity for at least 20 minutes. That's kind of the magic number, that 20 minutes, because that allows your brain enough time to get the signal from the liver, or your liver and brain to talk to one another, and that after 20 minutes of moderate intensity activity, that's when your fats start to get released from stores, and you will start burning fat more than your glucose from your glycogen stores after that 20 minutes, but it'll actually slow down the depletion of glucose. So you still have enough glucose to burn the fat completely if you're engaging in moderate intense physical activity for at least 20 minutes. So that's why there's this recommendation to engage in moderately intense physical activity for at least 30 minutes a day on most or all days of the week. If you go at a higher intensity, you're going to deplete your body of glucose more quickly, and you'll have to replete it in order to keep going. So for athletes who do engage in higher intensity physical activity, they can increase the capacity of their glycogen stores by adhering to a diet that is higher in carbohydrates, and there's this whole process that they can engage in called carb loading prior to an event, like a few days prior to an event. So we talked about role of body fat during exercise, protein needs of an athlete versus sedentary person. Athlete needs a little more protein to rebuild some of their muscle cells because they're engaging in activity. They're breaking down their muscle cells, so they need to rebuild those muscle cells. Micronutrients of concern for highly active people, especially female endurance athletes, is iron. Females are more susceptible to iron deficiency in general, but if they are, squashing their feet on the pavement consistently, they're breaking open their red blood cells, and they're also sweating, so they're losing iron. So the longer they engage in those activities, the more susceptible they are to iron deficiencies. Hydration schedule for physical activity. Yes, you need, more than any other nutrient, you need to pay attention to your water needs during physical activity. You will run out of water first before anything else. So you need to make sure you drink before, a little bit during, and after your physical activity. And you don't need electrolytes unless you're really engaging in activity for at least an hour at a high intensity and you're sweating a lot. And ergogenic aid, I'm not going to cover that on this exam. So for alcohol, I want you to remember the definition of moderate consumption. Remember, it's no more than 1 drink per day for women, no more than 2 drinks per day for men. Know the definition of a drink. We know that moderate alcohol consumption is associated with lower risk for cardiovascular disease among middle-aged and older adults, so people age 45 and older, but under that, not so much. What is this relationship between alcohol, moderate alcohol consumption, and heart disease? Well, it helps increase your HDL, your good, healthy cholesterol levels, and it helps reduce blood clotting. So that is a good thing. We talked about the detrimental effects of alcohol when consumed in excess in class. So moving through the life cycle, nutrition, start with pregnancy and lactation. We know why nutritionally adequate diet is important long before pregnancy is established, especially with regard to folate status. Remember, a woman of childbearing age needs to have adequate folate before she even becomes pregnant, before she knows she's going to be pregnant, before she is pregnant, because the fetus develops its brain and spinal column very, very early during pregnancy, and it requires folate in order to synthesize the DNA and replicate those cells that are rapidly dividing early in pregnancy. And if she doesn't have enough folate, the fetus may end up with a neural tube defect like spina bifida. Stages of prenatal growth and development, well, zygote, zygote, embryo, and fetus. Placenta, when you have a developing fetus, the placenta is the organ through which nutrients and oxygen pass from the mom to the developing fetus, and carbon dioxide and waste is exchanged back out from the fetus to the mom so she can dispose of that. Critical period, there are these critical periods during development during which you need to have, a set amount of nutrients in an adequate quantity in order for that critical period of development to proceed normally. If you've got a deficiency during that critical period or something other detrimental happens during that critical period, whatever's supposed to develop then does not develop properly. So again, with regard to neural tube defects and spina bifida, that's an example I've given you. And we talked about folate during early stages of pregnancy. Relationship between maternal weight gain during pregnancy. Remember, moms to be don't need to gain a whole lot of weight during the first trimester, but more so during the second and third trimester. But more importantly, we want to talk about the infant's birth weight. The amount an infant weighs at birth is really, really the single most reliable indicator of its health status. So low birth weight babies are 40 times more likely to die within the first year. So birth weight is really important as a health indicator. Increased nutrient needs of the mother during the pregnancy. She needs more of everything, basically. Remember, she needs folate, B6, and B12 for blood production, as well as iron and zinc and cell growth. And she needs vitamin D and calcium for bone development. The need for additional calories and fluids during lactation, sure, she's needs even more calories during lactation because she's producing breast milk. All right, so we talked about fetal alcohol syndrome. I don't think I have it on your exam. So let's move on to infancy to adolescence. During the growth phase, remember, growth is very rapid during the first year of life, and how we measure or assess growth and nutritional status of infants and children is through these growth charts. Two dietary practices that have the most significant effect on an infant's nutritional health are the type of milk it receives. So breast milk is best. Formula is fine, but breast milk is best because it provides some immunological protection that you don't find from immunological factors that you do not find in formula. But formula is not rat poison. And the other dietary practice that can have a significant effect on an infant's nutritional health is the age at which solid foods are introduced. So because the infant is born with only so much of iron and it's stored in its body, you need to start introducing solid foods between 4 and 6 months because breast milk is not a great source of iron. So it only has enough to last the first 4 to 6 months. So that's when you need to start adding solid foods that contain iron. Childhood obesity, we've talked about how prevalent it is. Sure, there's a role of genetics and environment. And with regard to environment, remember, we're seeing a lot of screen time with these kids, which means they're being sedentary, which is really just as important, if not more important, than excess food consumption. Nutritional needs of adolescents. Remember, teenage boys need more nutrients than any other period during the life cycle, except for pregnant and lactating women. But both teenage boys and girls need iron, but for different reasons. Girls, because they start menstruating. For boys, because they start gaining lean muscle mass, and that iron needs to be incorporated into the myoglobin that's present in that. We talked about how a teenager's choice of soda over milk may jeopardize their nutritional health. Remember, that's that phosphorus versus calcium ratio, and displacing milk with soft drinks can compromise their ability to achieve peak bone mass during their teen years. And the role of childhood obesity and early development of type 2 diabetes and cardiovascular disease. As we get more and more obese, regardless of our age, that does alone, obesity alone, increases your risk for type 2 diabetes and heart attacks and strokes. Moving on to the last stage of our life, physical activity in the later years. Yes, physical activity, again, it's important throughout your entire lifespan. Sarcopenia is this term that we define define as muscle wasting, that is loss of lean muscle mass as we age. So in order to retain your muscle mass, you want to work those muscles, and that's why physical activity is important, even a little bit. Nutrients of concern for aging adults. Certainly calcium and D and B12 requirements are different in older adults. Vitamin D is required in higher amounts because our body can't make it from sunlight as efficiently as when we were younger. And our body's ability to absorb B12 is impaired because we get lower stomach acid production. That's due to atrophy of the stomach. That's atrophic gastritis. And calcium, remember, as we age, we're losing more calcium than we're gaining in our bones, so we need to make sure you get enough calcium so you're not losing an excessive amount of bones, or you're slowing down the degradation of your bones. Nutrition recommendations for vision changes that occur with aging. Adequate vitamin A throughout your lifespan, but the antioxidants, foods that contain antioxidants, vitamin C and E, which include a lot of fruits and vegetables, are really good at preventing cataracts and macular degeneration, these age-related eye diseases. For prevention and treatment of arthritic conditions, well, primarily osteoarthritis, it's to lose weight. Common diseases of the aging brain, Alzheimer's, but also just aging brains need to make sure that they get enough B vitamin because B vitamins do affect cognition. I'm not going to ask you about the food-related factors that predict malnutrition. That is, I don't need you to know the acronym DETERMINE. I want you to be aware of it, though, but you don't need to know it for this exam. And I'm not going to ask you about commonly used drugs that adversely react with nutrients, although, you should be aware of them as well in your own life and those you love. For diet and health, this is the wrap-up lecture. I want you to know the important lifestyle factors, that is, the modifiable versus non-modifiable risk factors. What are the things that you can do absolutely nothing about to affect your risk? That includes age and gender and genetics, your family history. But what are the things that you can modify? Your diet, certainly, your lifestyle, your choice whether or not to engage in physical activity or detrimental lifestyle choices. We know about a lot of the dietary factors that can help prevent disease, but there are also chronic diseases like obesity that in themselves are risk factors for diseases like increased risk for cancer, increased risk for atherosclerosis, increased risk for hypertension. Remember, atherosclerosis and hypertension exacerbate one another, and they can both lead to strokes or heart attacks. And being obese can increase your risk for developing type 2 diabetes, which in turn increases your risk for cardiovascular disease. So specific nutrient recommendations for each of the major chronic diseases discussed. Well, most of that is going to come from part 6 of your diet project, or the last part of your diet project. But you should be aware of, that DASH diet can help reduce hypertension. Some things to prevent cancer include, just what you would expect, a diet high in plant-based foods, and that's the case for most of these conditions as well. I'm not going to ask you about how nutrition impacts the immune system, and I do just want you to be aware of the fact that the dietary guidelines for Americans, which are depicted in the MyPlate icon, really do promote a diet pattern that is compatible with a reduced risk for all of these diet-related chronic diseases, because it emphasizes fruits and vegetables and whole grains and plant-based sources of proteins. It does, that's the whole reason why we have these guidelines, to prevent these diseases that afflict the majority of Americans. And then finally, food safety. Food safety first and last. 2 ways in which foodborne microorganisms can cause illness in the body are infection versus intoxication. So you should know the difference between those two. Most food safety or most foodborne illnesses are due to a food infection. That is a microbe. That is a bacteria or a virus or a mold that gets into our body, that divides, sets up shop, and makes you sick. So there are ways to prevent foodborne illness during production and service, particularly using, as your food goes from farm to table, HACCP, Hazards Analysis Critical Control Points. You should be aware of that one and how that's defined. The 4 components of food safety in the kitchen, good old fight back. So that's clean, separate, cook, and chill. You should know what each of those components is and how they're defined. Environmental contaminants in the food supply. I'm not going to really ask you about those. Potential advantages and disadvantages associated with organic foods. We talked about that in class. Common additives in the food supply and their risk and benefits. I don't think I'm covering that. And nothing about the risks and benefits of genetically engineered foods will appear on your exam. Okay, so that's the second half of your semester in a nutshell. I hope this helped. Of course, if you have any questions, please reach out and we'll be happy to help you out. Good luck.